This is the first video on matrices, so I'll just write it out for you. Matrix is a singular, and we write matrices as the plural to mean more than one. So, what is a matrix? A matrix is a mathematical tool for storing a whole lot of information. It's a little bit like a database, but it's one we can actually manipulate using algebra. So if you're used to seeing formulas such as y equals 2x plus 3, which is a relationship between some unknown y and the variable x, then this is a pattern linking those two things together. And you might notice that's a linear graph. With a matrix, we can link a whole lot of these patterns together, and I'll show you first with an example. So here's our first example. We've got three ranges working and looking at feral animal sightings in a park. So example just down the bottom here, just showing you bit by bit. So they record their sightings in this matrix here, matrix X. So this is what a matrix looks like. It's a series of columns and rows with a bunch of numbers in it. So it's a bunch of information sorted in a logical way. So the rows here are the different ranges. So we've got Aaron, Barra, and Chloe. And the columns in this matrix represent the different feral animals that they've seen. So for example, this number here, 27, means that Aaron has seen 27 cats. Whereas this number here is that Barra has seen 89 rabbits. So that's how matrix X stores all this information in quite a logical way. When we look at matrices, we can do a bunch of things with them which can be quite useful. So one thing we can do is look at, this is a form called matrix multiplication. Now I'm going through this as an example so you can see it purpose. We will go into this in more detail later. But when we look at S multiplied by B, the way we actually do that is we take each of these numbers here, we twist the matrix around, and we times this number here by that, this number here by the dogs, this number here by the foxes, and this number here by the rabbits. Then we add them all up. So 1 times 27 is 27, 1 times 9 plus 9, 1 plus 34, add 34, and then add on 59. So we have this database of information, and then we've got this second matrix, which is just a column of ones. So evaluating S times B, you would add those numbers together. So 27 plus 9 gets us to 36, plus 34 gets us to 70, plus 59 gets us to 129. What information does that give us? It gives us the total number of feral animals that Aaron has seen. Okay, then you could also look at A multiplied by X. This is a slightly different one because it's this form just here, it's this horizontal one. We actually take each of these and multiply them by the columns. So we multiply 1 by 59, 1 by 89, 1 by 29, and have a look at what that information gives us. That information would tell us the totals. So it would actually tell us the total number of cats that are seen, or the total number of dogs that are seen, or the total number of foxes. Okay, moving to the next slide. So, a bit more of a clear explanation. The matrix is a rectangular group of numbers set out in columns and rows. We just saw that before. This Aij is one of the elements. We'll talk about elements in a moment. But we've got the rows running downward. So this is just like as if you were seeing in a table. So, set of rows. And we've also got a set of columns. So yeah, it's almost like you're storing these numbers in a table or an Excel spreadsheet, but they're quite useful in that we can actually multiply them, we can add them, we can subtract them, or we can times them by just a single number instead of another matrix. So we can do our mathematics directly to these things, unlike a table where it's just the information that it is. You don't multiply one table by another. All right, basics of a matrix. So here's another example. A market stall operates on Friday and Saturday. Sales could be recorded using this matrix here. So we can read this information. On the Friday, so these are our two rows. We've got Friday and Saturday, row 1 and row 2. And then we've got shirts, jeans, and belts. On Friday, 8 pairs of jeans were sold. That's this bit of information here. So we're saying go across from Friday, down from jeans, and that tells us 8 shirts. So it's just literally just a table. On Saturday, 1 belt was sold. So that's just here. The total number of items sold on Friday, we can just add up all of these here. So add 6 plus 8 is 14, plus 4 makes 18. The total number of belts sold in total, we add the numbers in the column. So that's 5. All right, the order of a matrix. The order of a matrix is what we refer to, well, you could essentially think of it as the size. It's how big the matrix is. In our previous example just here, the matrix had 2 rows and 3 columns. So it's, again, just the size of a table. But we call this the order for a matrix. So we've got this one here. It's the number of rows multiplied by the number of columns. So this matrix is a 2 by 3 matrix. So is this one. We have a look at some of the matrices here, some examples. I'll just zoom in slightly so it's easier to see. Sorry, losing it there. So we've got the order of these matrices. This one has 3 rows, 1, 2, 3, and just 1 column. So it's a 3 by 1. This one, 2 rows and 2 columns, 2 by 2. This one has 2 rows, 3 columns, hence 2 by 3. This one, just 1 row and 3 columns, 1 by 3. And an individual number sitting in this matrix just makes it a 1 by 1, 1 row, 1 column. All right, elements of a matrix, another word that you need to get used to hearing. Numbers within a matrix call its element. So each of these numbers just above here, which was representing the number of a certain amount of items sold on a certain day, each one of those is an element of the matrix. So it's numbers that are sitting within it. And we have a convention for how we write them. If we were to call this matrix A, then each element gets referred to as the lowercase a, and you'll sometimes see I and J. Now this can take a little while to get used to. The I refers to the number of rows, and the J refers to, so just here, the I is rows, and the J is the column. So if we were, for example, looking at this element just here, that's A1, 1, row 1, column 1. This element just here would be called A, row 2, column 2. And this one here would be A, row 2, column 3. So A2, 3. So each of these are the elements of the matrix. Okay, quick example before I set you up to do some questions. Matrix B shows the number of boys and girls in year 10 and 12 at a particular school. So I've got year 10, 11 and 12 as our rows, 11 and 12, and the columns are boys and girls. Give the order of the matrix. So that's rows by columns, and it is 3 rows by 2 columns. So it's a 3 by 2. That's the order. What information is given by the element B1? So remember, 1 is the row, 2 is the column. So row 1, column 2 is this number just here. And that tells us the number of girls. Let's use this to mean number of girls in year 10. Which element gives the number of girls in year 12? So the number of girls in year 12 is just here. And because this is called matrix B, we'll use a lowercase b, and it is row 3, column 2. So B32. How many boys are there in total? So that is the sum of these, 57 plus 48 plus 39. So just add them up. And how many students are there in year 11? We would add these two numbers just here. So 48 plus 54. All right, start on section 1 of the workbook. Go through until you get up to section 2. It'll tell you when to watch the next video.